Okay, so in the case that the nullity is 2, well, since the rank plus the nullity has to equal 3, the rank has to be 1. The rank is your dimension of the row or column space. So your row space and your column space would each be sketched as each be identified as a straight line through the origin. So if this is your row space, your column space might be like this. You know, it could be at any angle depending on the transformation, as could your row space. And your null space would be a plane through the origin. Okay, so maybe your plane is kind of like this through the origin. Your row space is kind of like this, perpendicular to the null space, because it has to be perpendicular to the null space. And if a point on the row space maps let's say this point maps to this point on the column space, okay? Then any point that you can get to from this point by a vector in the null space will also map here. So you have a whole plane parallel to the null space plane, but not through the origin, through this point, okay? And I guess I can attempt to sketch that. Now, of course, the plane goes over all space, but I don't have room to draw the whole space. So I'm just drawing a little section of the plane through the origin here. Well, your null space, well, if this red plane is parallel to this plane, I didn't do a good job of drawing that, but it goes through this point, then any vector from this point to a point on this plane, and those vectors would be parallel, let's say, to this vector and this vector and this vector in the null space. All of these points and any other point you can get to on the same plane would map to this point. Okay, so any such plane will collapse to a point in your column space. The null space plane itself will collapse to the origin. And the null space is, again, perpendicular to the row space. So the angle between this line and this plane is always 90 degrees.